Hello, everyone, and welcome. Thank you all so much for joining this live stream event today. My name is Alexia, and I am the project and event manager at Microsoft Reactor Toronto. Before we begin, I'd like to go over two items with you, our code of conduct and our event guidelines. Please take a moment to review our code of conduct. Microsoft Reactor seeks to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. Secondly, our event guidelines. This session is being recorded. It will be available on demand through our Microsoft Reactor YouTube channel in about 24 to 48 hours. I will be sharing the link for our YouTube channel in the chat. And if you've not been on a live stream through YouTube before, please note that you must create an account on YouTube in order to access and interact in the chat. You can set that up now, and if you're unable to use the chat but have any questions, feel free to reach out to us on social media or on Meetup. Which brings us to today's session. I'm going to bring in our speaker here.
Hi.
Hi. How's it going today?
Oh, all good, all good. Thank you for having me here, and yeah, with all of you.
Of course, yeah. Thanks everyone for joining one more time. This is the first, I guess, episode of your 2-episode series. We have today's session as well as next week, same time, same place. Yep. So yeah, super exciting. Okay. And yeah, take it away.
Okay, awesome. Again, thank you for having me here today with all of you. I am sharing my screen. I suppose you are seeing a little bit about me. My name is Matías Iacono. I am from South America, but currently I'm living in New Zealand. I've been living here for like 4 years and a couple of months. And as a brief introduction about me, some of contact information that you can, if you want to contact me and, or I don't know, follow me on Twitter or see my LinkedIn profile. There you have some links, and perhaps the most important one is my repo, in which I will be, you will be able to find all the code that we will be showing and seeing today there. So if you want to, I don't know, review the code and play with the code and so, I don't know, make some changes and that kind of things, funny things, just go there and you will be able to do it. The rest of the stuff is just anecdotal. Pure history. So today we will be talking about a couple of tools that we have, or a couple of tools and frameworks that could be very, very helpful for us when we are talking about computer vision and how to implement some approaches and models and train models, but we will be talking about a little bit later about that. But these tools and these integrations is interesting to actually understand it or have it if we are trying to implement something quickly, or something that I don't know can give us some kickstart on the project that we want to later, I don't know, enhance or improve in some way. So again, we will be talking about, or we will be trying to join these 3 main tools, and in the case of the Raspberry Pi board, a particular microcontroller, with Lobe AI, which is a tool that we will be exploring in a few minutes. So when we are talking about computer vision, usually the thing, if we are new on the topic, the picture or the image that we can, or we could be having in our heads is something like this. And this makes me a little bit of fun, because again, when I started on this, my understanding of computer vision was like, oh yeah, I am seeing all these videos or pictures in which we can detect where people are, or if in the picture there are people, or if there are some cars. or some kind of signals and that kind of things. And I thought that actually computer vision was that. I mean, detecting objects in a picture or in a video, and then saying, oh yeah, this is cool. But actually, when we are talking about computer vision, there is much more there. Actually, when we start exploring on computer vision, we see that this kind of approaches is just one tiny piece or one tiny knob in the whole idea of computer vision, and we can actually do much more, or even we can take only one small piece on this and create another type of implementation, or create another a more specific product or implementation that we will be able to use then in our products. So just as an example, in this picture, we have detected, suppose, a car, but actually we could want to not necessarily detect a car, but actually detect the plate that this car has. And from the plate, once we actually know that there is a plate that belongs to a particular car, we can, or we could, we will like to actually know the numbers that we have here. And with this value, or these numbers that we got from the plate, go and actually do some kind of data validation. So it's the same case for this person here. We know that there is a person, but actually our implementation, I don't know, could be based on the idea of if it's running to the right or to the left, or if it's running, or if it's not necessarily running, but doing some kind of exercise, or doing, I don't know, is in a particular distress. So it's not just detecting objects, but it's more like trying to understand or making the computer to understand what is in the picture, and from there extracting information and creating something, adding some value to creating some value based on that information. So if we have that in consideration, we will understand that we have different types of application, but not necessarily not the final application, but the different approaches that we have, or different mathematical propositions that we have when we are talking about computer vision. So again, one could be object detection, but the other one could be just parsing the picture. Some image that has something that we as a human understand, such as numbers or letters, but translating that into something that the computer can understand as numbers and letters. So again, different ways to implement computer vision, and it's not necessarily only related to this picture. So in today, and as I said at the beginning, we will be using three main tools. Well, one is more like a board, is a physical thing, and then we have two applications. One is called Lobe, and the other one will be Tensorflow Lite. If we go a little bit deeper on this, we will see that each one of these tools are used for a particular part of or pipeline, to say in that way. So we have one tool, which is Love, that will help us to create a model, a computer vision model, optimize that model, and actually train the model, which is one of the key concepts when we are talking about computer vision, or even when we are talking about artificial intelligence and machine learning in particular, where we have something that we want to solve, and we need to train and the computer to do or to produce the results that we are expecting. So that training, that mathematical proposition that we are creating, and the training that we are giving to that is based in this case, or we will be using this tool to accomplish that section. Then we have TensorFlow Lite, which is if we again, if we are not necessarily familiar, this is our first approach to computer vision. The thing that we can think about TensorFlow like the heart, the engine of or processing pieces. So we will have the model that we have created, and then we will use a particular engine to run that model and produce results. So in the case of TensorFlow Lite in particular, is a subset of TensorFlow, which is like the superset, the big one, that or allow us to run this inside of low profile devices, we will call it in that way, or low consumption, energy consumption devices, especially mobile devices such as Android or iOS, or Android or the Apple ones, which even if they are very powerful devices, requires or has less power that compared with the computer that I have here in my desktop. So we need to have an engine, something that can run these models in a way that will be actually able to do it inside of this type of devices. And actually TensorFlow Lite allow us to do it inside of a Raspberry Pi. And I'm pointing here because I have a Raspberry Pi here, and then I will show you all the configuration, and we will be talking about this a little bit. So having the model, having the engine or the component that will run this model, we need some place in which we will be executing that model, and also a place or some kind of box that is able to sense the external world, the real world, and feed in some way what is happening in the real world, and feeding that to the tool and producing some results. So in the case of the Raspberry Pi, which is again is not necessarily the lowest or the most low profile computer that we can find in the market. I mean, we have Arduinos, or even boards that are even more light and that consumes actually or requires less energy and has less memory. And I mean, we have even smaller boards, but the Raspberry Pi again is small enough compared with my cell phone that I have here in my desk or my computer. So still is a very, very low profile computer. So having all this or taking all this together, we can just put it inside of the Raspberry Pi, make the Raspberry Pi see the external world, and try to produce some results. So yeah, that is basically the plan. So let's try. Oops, I think I pressed the wrong button. Give me 1 second. My bad. Okay, now we are good. So if we want to, as I showed in the presentation, the first step that we need to accomplish is to actually have a model, train the model, and make sure that actually the model is producing the results that we are looking for. So for that, we have Lobe, and a thing that I haven't mentioned, this is a free tool, is a Microsoft tool that is currently on build. I mean, it's free. You can go to the website, download it, and use it. And is planned for the future, the future or the roadmap on this tool to incorporate new mathematical propositions. And when I say mathematical proposition, it is different ways of do computer vision. As I mentioned earlier, one was when we saw the picture, this big picture with all the boxes. One is detecting objects, in which give us the possibility to know if there is a person or a car or a bicycle or different objects in the picture. But then we have other options, and in this case, the only implementation that we have here is one that is called image classification, which is basically having different categories of images, we can, or the model that we will be producing can detect or decide, to say it in a better way, decide if what we are presenting belongs to a particular category. So suppose that we define a set of pictures for category A, a set of pictures for category B and C and D, and then we present a specific picture. The model will be able to say, oh yeah, that picture that I am seeing, or that video stream, or any visual input that we are providing to the model could belong to category A or B or C or D. So basically, that is what we can do with Lobe, and it's really, really, really simple. So I will create a new project, and I will call this project Docs, which is we'll have a meaning in a moment. So in here we have basically three options. One is labels, one is training, and one is use. And labels actually belongs to the or refers to this idea that I was explaining a few minutes ago, which is creating. I mean, a label is actually a category, so we can create category A, which is label, the first label, category B, which is the second label, and assign pictures or assign data to each one of them, and then make this application, make Lobe to calculate, compute all of this, and train the model, and produce some particular result. So to do this, I will go here, import. I will import images, and I have already downloaded a set of pictures that belongs to different dog breeds. And this one is a free one. I mean, it's a free set of pictures that is recommended to be used when we are testing a computer vision model based on image classification. So this is free. This belongs to, I don't exactly remember the university, but if you search for dog breed image classification, computer vision, something like that, this will appear. And again, basically is providing me with a lot of pictures based on a particular dog breed. So I will take the first one, and because just I don't know how to write Chihuahua, I will copy that part. So I will go here and select all my pictures. And as you can see here, we have imported all those pictures, which actually is not only the dog that we have here, but also, as you can see, there is a person, there is a lot of grass. There is a lot of different type of, puppies and old ones, and actually this is mad. And yeah, so we have many different type of pictures with different backgrounds. Tiny ones, big ones, some with more in the foreground. So this is like real world pictures that belongs to this particular breed. So what we will be doing here is I will select all the pictures and say, okay, this is my set, my label, or all of this belongs to category, or to this category, which is Chihuahua. And as you can see here, now we have inside of the labels, we have all the pictures, which are all the pictures that we have actually imported. But we have one label, which is the one that we just assigned. So at least to make this work, we need at least two categories, or at least two group of labels, because cannot be categorized, or we cannot have a machine learning model with only one that will be able to categorize between one breed and the other if only knows, or the model only knows only one breed. So I will repeat the action, and now I will go here and select Japanese Spaniels. And once we have all this imported, I will just remove this. Now we have two labels. One is a Chihuahua, the other one is the Japanese Spaniel. This is the last one that I imported. And as soon as we have at least two labels, we see that now is automatically training the model. So, and this is quite interesting because for Love, for this on this application, we are not necessarily specifying what we want to classify. It's just trying to do it best to understand the different two categories that we have in this case and say, okay, yeah, there is some significant differences between them, and try to create and train the model based on those differences. So what it's doing on Behance is basically going through all the pictures, and while it's training, comparing the pictures that we have provided and see if the mathematical approach that is creating is actually producing the results. So it's saying, oh yeah, I have a Chihuahua, so I train the model, expose or use this picture in the model, in the model that I am training, and see if actually I'm receiving an okay saying, yeah, this is a Chihuahua, this passed the filter, to saying that way. So clearly we have finished the training, right? So it says that we have 99% of the predicted or the image that we use were predicted correctly, and only one incorrectly, which is interesting because it's saying, oh yeah, I understood that this is a Chihuahua, but actually was a Japanese Spaniel. Looks like a Japanese Spaniel, right? So we can go here and say, oh, no, this is clearly a Japanese Spaniel. So in the moment that we make a modification, the model is trained again, and is again try to be optimized and try to create a better approach to the model. So now that we help the tool to a little bit just on the training, now we can see that both of the categories are 100% correct. So that means that with the picture that we could have, if we use this model, we will have 100% accuracy every time that we use it, at least with the set of pictures that we have here. So now we are happy. Now we know that this works, and we will try to use it. So there are many ways to use it. One way is we can feed or we can use a picture. This time, yesterday, I haven't downloaded a picture. I think that now I have a picture. This is a Japanese Spaniel according to the search engine. We can open it. So it looks like a Japanese Spaniel. I am not an expert on this, but I will select this picture, open up, and says, oh yeah, this is a Japanese Spaniel. Actually, the result of this test is saying this is a Japanese Spaniel. And actually, yeah, it's right. So that means that we have, the model is working as we could be expecting. So we can basically say, no, this is not. We can say, yeah, this is right. And if we actually press here, this will be added into our pictures, and the model will be retrained. So which is something very, very interesting, because we can constantly increase and feed the model that we have and improve it directly from here without worrying about too much of what without all the nonsense of knowing what is going on in the background. So now if we go here, we will see that my picture now was added into this category, and yeah, so that was used to retrain the model and create a new results. Also, what we can do is use the camera, and I have here what you are seeing here is my I don't know, it's like a green screen that I have prepared here. So, but if you see this camera, I have another picture of a Japanese spaniel. So I will try to put this here and say, yeah, this is a Japanese spaniel. So again, using a live stream is detecting that it is a Japanese spaniel. If I take out this one here, you can, I mean, it's easy to spot that says this green screen that I have here is a Chihuahua, which is not. But the reason for this is because we haven't defined a category that is not a dog, basically. So by default, this model, what it does is, if cannot categorize the element, uh, it will basically fall back to the first one. So everything that is not a Japanese Spaniel and is not a Chihuahua is a Chihuahua. So this is something that we need to, in some point, we need to create, again, a new category that is, this is not a dog, or this is any other thing. And it's part of our training. But for this experiment that we are doing here, we are not necessarily doing that part. So in any case, we are happy now with our model, and the next step is to export the model and see if we can actually move it to or into the Raspberry Pi. And this is another interesting thing from Lobe, which is we have different ways to export this. In this case, we are exporting the model, but also we have some GitHub repositories in which we can see, for depending on the type of application that we are trying to build, we can go there and see, have access to some source code that will allow us to consume the model and interact with the model. So in this case, suppose that we are looking to run this in the web browser, we can see this React application, which will use our model and will present us a standard React application that is able to read the camera and do basically the same thing that we did here when we were testing the model. So yeah, it's a very nice starting point, and the same for the other type of applications. In our case, in our scenario, we are a little bit bolder on this, so we will be just getting from Lobe the models. So in this case, we can export this to standard TensorFlow, which can be used not only by Python, but by C++ or any other language that actually has support and libraries for this. We can export the TensorFlow Lite, which is the one that we need. And then also we could actually exporting this to TensorFlow GS, which is the same version of TensorFlows. I mean, this is part of the family, but runs in the browser or is easy to be executed in the browser. So I will export this one. Yeah, we can put it there. It's fine. And just to make it fast, I will just say just export. We could actually try to optimize the model. This will take longer. So I will just export the model, because we will not be using this model in particular. I already have the model inside of the Raspberry Pi, and because we don't need to waste too much time copying the files into the Raspberry Pi. So it's just for us to see it. So this is the result. I don't know if I can. No, I will not be able to zoom in, but it's fine. So basically, we are getting these three files. Labels basically has the categories that we have created: Chihuahua and Japanese Spaniel. Then we have the model itself, which is this one, that is quite, for the amount of picture that we have, is quite small. It's only 15 megabytes. And then we have this is a JSON file with some additional information regarding the model and the size of the the size of the picture or the input pictures that we should be sending to the model or using with the model, and other configurations. So all these three guys here are basically our model, and this is the one that we need to use to run and execute this inside of the Raspberry Pi. Also, this is very, very helpful from Lobe. If we go to the example part, actually we have as a gift, to say in that way, a couple of lines of code in Python that will tell us how we could actually use and consume that model. So even if we don't know how to do this inside of a Raspberry Pi, or even in standard with the standard TensorFlow model that we could create, we have here free code in which we can go grab and use it, which is again is quite amazing. So but again, we will not necessarily be exploring that one. This is in the case if you want to use the tool. I mean, you want to use Lobe, you don't know, after creating the model, you don't know how to continue with the implementation. You have here some examples. So let's assume that we have just export everything, and we have everything ready inside of the Raspberry Pi. So I have here another camera, hello, which is pointing to my Raspberry Pi. This is the Raspberry Pi that I have. This is a standard one. It's a Raspberry Pi 4. And you can see that in my configuration, I have, you can see my hand here, right? I have connected this small screen, and this is only, in my case, it's only just for feedback. I mean, it's to see what is going on, but actually it's not mandatory, because actually most of the solutions that we could be implementing with this is just the Raspberry Pi with some sensors such as this one, and just running without any visual feedback, right? So we could have this sensing the external world and then sending information through the network to a particular place, and then we can analyze that information or do something with that. So so talking about the sensors that I have, this is a very small camera that I have connected to the Raspberry Pi. This is a 5 megapixels camera, I think. And then I have here, this is a very small, like this. This is a very small electronic ink display. It's quite slow, but yeah, it's a nice one. So again, this is the standard configuration or a basic configuration that I have. And you could actually get rid of the display. So let's connect to that Raspberry Pi and see what we have there. I will enlarge this. In the last session, we realized that was too small. Okay, so that should be better. Okay, so we have, I mean, I am connected to the Raspberry Pi. I will just leave the camera there just to see what is going on. And we're going to here. So again, I already copy and pasted the model inside of the Raspberry Pi. I have it here, and we will be seeing this in a moment. But the first thing that I usually do in here is actually to try to test the camera, because the camera in this case is my only point of contact with the external world. I mean, it's the only way that I have inside of the Raspberry Pi to sense the external world and actually feel or test the model that we have created. So I will go with this, and you will see here that actually is appearing. This is the reason that I have this visual feedback just to see if something is working, or I mean, if this is working fine. So I ran the code. This is pointing in that direction, so just show that. And then, so yeah, the camera is working, and we can take a quick look on this. And we will see that actually the amount of line of code that we have is really, really small, and actually is quite intuitive. I mean, it's not necessarily too complicated to understand it. If we see this, we will notice that basically what we are doing is importing our library for the camera. This is very well-known package that we can use to access the camera. Some additional information just to save the picture in the or save some information in the inside of the Raspberry Pi. But yeah, the most important part is this one. So then we are creating that camera. We are setting up the resolution for that camera. In this case, it's a very small one. Then we are making a preview of the camera, which is the reason that we saw here the camera appearing. We wait for 5 seconds, and then we capture one of the frames that the camera is seeing and save it into the disk, and then stop everything. So just with, I don't know, 6 lines, 5 lines, we have an application that is able to open up the camera, take a picture, and save it into the disk. And actually, if we see here, this is a picture, right? So we could actually open the picture and see that is basically my fingers where in the moment that I put it there. So yeah, we have everything there. This is actually the starting point for our testing with the TensorFlow. I mean, with this model that we did, because basically what we need is a way to capture a picture and process that through the model that we have created. So, oops. So if I see, if we go there, we will see, I mean, this is where I copied and pasted the model. So if we see this, I mean, if we explore a little bit, we can find that we have the 3 files that I've been mentioning, or I mentioned a few moments ago, which is the labels, I mean, the names, which is the Chihuahua and the Japanese Spaniel, the model, and the JSON file. So basically, we copy those 3 files and put it there, and that is all that we need so far. So then I have this predict pi is the code that we will be running to predict or to run this model and try to make a prediction, and I will run it and see what happened. Then we will be exploring a little bit this. So again, you can see that it's trying to take some information there, and again, this is very small, but it's saying Chihuahua here, and the reason for that is again because if there is no dog or is anything or whatever is seen, is a Chihuahua, right? It's the same thing that happens with when we were trying or testing Lobe for this. But again, or also we can see here down here that is saying the label that is decided or was categorized is the Chihuahua one. The confidence for the model is 100% that this is a Chihuahua, which is clearly not, but again, it's the fallback. So I will take my Japanese Spaniel picture and try to put it there. And now you will see that in the moment that is detecting that it's a Japanese Spaniel, the console is changing. I know that you cannot see the Raspberry Pi right now, but it's saying that it's a Japanese Spaniel and it's 100% sure that it's a Japanese Spaniel. So clearly it's working, it's detecting this, and it's applying the model that we have inside of, I mean, we are executing that inside of the Raspberry Pi, and we are able to sense the external world, see using the camera, see a picture, and then send that picture into the model and make all the magic happen. So let's see a little bit the code here. And we can notice, I mean, again, the same that we saw in the small code that we saw earlier. So we have the camera, or we are referring to the camera, and one of the most interesting part is that we have a particular package that is for, in this case, Love, for the same application. So we can use this package to actually load the model that we have produced, the TensorFlow Lite that we have produced, and consume it from our Raspberry Pi, and in this case, from Python. So we don't even need to, in the same way that using Lobe, we don't need to worry about the small details about computer vision and how to train a model and all this most complicated part of computer vision. We also don't need to, using this package, we will not need to actually worry about how TensorFlow actually works and all the, again, the fine grain, the small details about how to configure TensorFlow. So even with this, we can avoid all of that and have a very quick and fast implementation of our models and create a basic or simple application. So yeah, we have here this, and we basically are repeating the same process with the camera, but just adding a small part related to TensorFlow. So here we are loading all the assets that we have in that folder, the model folder, in which we place the 3 files that we produce with Love. And this is our model. So again, this is just loading that and creating the model. Then we are setting up the camera. In this case, again, very simple. We are saying that this is the resolution, this is the expected frames per second that we would like to have, and yeah, there is not too much else to do. Once we have the camera, we start the camera, wait a couple of seconds just to give some time and space for the camera to start, and then we are going through a loop that, because we are trying to all the time see what is going on in the external world. So we are just going constantly trying to read the camera and process that through the model. So we go through this loop, and here we are getting an image from the camera, and we are saying to the model, okay, with that image, make a prediction. Once we have the prediction, down here, we can see the labels based on the prediction and the confidence based on that. I mean, this percentage that we saw in the console. And then down here, the rest is just calculations. I mean, to know that how much the prediction took and that kind of things. So it's just basically random code that we don't necessarily need, and that is the reason that I am just keeping this. But here we are basically printing that. I mean, printing the prediction or the label, and then percentage based on the prediction. So again, we can reduce this on to just a bunch of lines. I mean, no more than 10 lines, and we have the TensorFlow running, being executed by the Raspberry Pi, and actually predicting something from the external world. So, and the rest is nothing else. I mean, it's very, very, very simple. So, again, we don't need to invest too much to actually have this running. I mean, we started 40 minutes ago, and we have trained a model. We have run this in a Raspberry Pi and actually get real predictions from the external world or through the camera. So in 40 minutes, we have this kind of completed. So the last piece, and this is perhaps the part that is like a plus that we can see, is that they have exactly the same thing, but in this case, using this particular screen. So I will run this guy here, and this should be actually trying to, instead of using um, the display, the big display that I have here, we will try to use this screen and see the predictions there. So again, this is not nothing mandatory, or you don't necessarily need to have the same devices or the same components. But it's a way to see or to show that it's quite simple to get this working and using external or different devices, different components to to create solutions with computer vision. So I will put my Japanese spaniel here. Okay, this is a Japanese spaniel. So now the screen is refreshing, and once it's finished, we shall be able to see that now the text is saying Japanese spaniel, right? Even if it's not on focus, but yeah, clearly it's a Japanese spaniel. So it's really easy to keep us adding new components and new elements inside of this Raspberry Pi, and using exactly the same model that we have trained in the beginning. Keep this evolving and adding up more elements. So and just to make a quick overview on this, because this is the difference with this code and the other one, and the one that I showed previously, is only the part in which we interact with the display. So the display has its own particularities. I mean, is something that we need to learn how to use it. So the only piece of code that we are adding is this section, in which we are taking basically the text that we want to show, which is the prediction. This will be the Chihuahua or the Japanese Spaniel, and then we are showing this down here and down here. But again, this is very specific of this particular electronic ink display. So it's not related to the implementation, the computer vision implementation that we have done. So this is very specific for this display. So, but with a very small lines, we still can display something, or display the prediction, in not necessarily in this big display here, but instead of this small display that we have here. So I think that is all that I have. And just to show again this, thank you for all of you for listening to me today and to be here. And again, the source code and all the material can be found in my repository if you want. And I am open to questions, if there is any. Let me see. I am reading. Okay, we have one from David Wong, which is what will the minimum version of the Raspberry Pi will you recommend? I have tested this only in the Raspberry Pi 4, but I know that actually, as you mentioned, the Pico and the Zero has the ability to do exactly the same. So you could actually be running this using one of any of those. I have a Raspberry Pi 3B somewhere in my stuff, but I haven't tested there. I know that you can work. I mean, you should be able to do it. The only thing that you need to make sure that you have is the correct Python version, because we are running this in Python. And if you can run that version, I am running 3.8, I think. If you can run that version, should be good or should be enough to run it. So yeah. So another question from David. For machine learning image recognition software, what language do you recommend learning focus? Usually the most, depending, again, this depends of the implementations that you want to do. That could vary, but clearly the most well-known and the most recommended is Python. And not necessarily, I mean, there are different reasons because of that. One is quite simple to use. I mean, if you saw the code that we explore, with very few lines, you can achieve a lot. And the other thing is that the libraries that you have there in Python are quite complete. I mean, are very wholesome. You have a lot of libraries that you can use, and again, with very few lines, you can achieve a lot. But in any case, again, it depends of your implementation. C# has evolved a lot and has a lot of tools around this. And if I need to, I mean, again, depend of the project. But if I need to, or I have the possibility to choose between C# and Python, perhaps I will pick C# in some point, because that will have a different impact in my team and my knowledge and that kind of things. But again, depends. Usually, will depends of the implementation. So Python will be the first, maybe, and then depending on the solution, C#, C++ could be the second options. So we have another one from Kirby. Is it possible to pick out a moving object rather than a static shown? Yes, but remember that in this case, okay, home and moving object. Yeah. So remember, in this case, we are talking about image classification. So we need to we need to understand that we are trying to categorize something still. I mean, always we are actually seeing something still, right? So we are taking one frame from the camera and analyzing that frame. Even if we are trying to analyze moving objects, we are doing this frame by frame. So in this particular implementation, this model, we are trying to categorize between, or we are trying to classify between different categories. So we are taking this picture, we are trying to see what is in that picture and see if this can be put or fit a particular category. In the case of moving objects, we need to take one picture, then see if there is something there, take another picture, calculate how much time passed between them, and see if the same object is in the same place, and calculate if this was moving or not. So there is a completely different approach that is not it's not necessarily achieved using image classifications. There are other models or other ideas in computer vision that will help you to do that. So in the case of Lobe, the tools that we use, the model will be quite, the model that we produce will be not that useful for that type of implementations. So I will recommend to go through a different approach. Where can we find pre-built models? Okay, that is a good question. And let me show you something, because I haven't shown this in the previous yesterday. So let me show you something. Share screen. I will share again. And so actually, again, I don't necessarily know. Usually, I mean, there are many pre-built models. Usually, you need to buy it, but also there are companies that actually release those models for free. So what I have here, this is, oops, sorry, this is the GitHub repository of TensorFlow. So you can download this one. And in here I have this. I mean, you have a lot of examples here. Even suppose we have this image classification, which is one of the approaches that we use, but also and this, sorry for the branching out this at this moment, but if you see here, you have a lot of different examples, and I am trying to see if we have something that actually is able to classify moving objects and that kind of things. But anyways, so going to the image classification part, we have one specific for Raspberry Pi, and in here, if you see this one here, this is a model that is provided by Google, which is free for use and has the ability to it's a pre-trained model and has the ability to detect different type of objects, not only classify in the way that we did it. I mean, not not for only for dogs. It's like if you point this to or using the camera, can classify I don't know, a curtain or a microphone or a cell phone, a person, and that kind of things. So if I run this, this was classify. Let me see if it works. Oops. And oh, yeah. Sorry. This is and I remember the reason why I didn't show this, because we hadn't the time to explain some stuff in here. But let me run it from here. Basically, the error that we are having is using the console. This example is trying to use OpenCV, which is another tool that renders or requires some access to a visual GUI or a visual GUI. Graphic user interface, so I need to run it in a different way. So yeah, and that was the reason why I haven't shown this the other day. But just we are over the time, but over the hour. But I really would like to show you this, guys. So image classification, Raspberry Pi. Python classify. So now we should be having this. And if you see, if I point this to me, it's saying there is a, I don't know, a mosquito net. Yeah. So all of that, right? So it's saying there, maybe it's, yeah, curtain, right? So it's showing different type of, or it's trying to detect different type of objects. I know that it's not clear enough, but in there we have, yeah, fan, microphone. So it's appearing different things. So, but this one is a free model. It's a pre-trained model. This can be downloaded. I mean, if you download the GitHub repository for TensorFlow, there is a README there, which lead you to how to download that and how to use this free model. So there are many free models, you can, or pre-built models, and you can I mean, you need to search for them. I don't have sadly the links, but that is one of them. That is one of them. So I hope that helps you. Okay, I suppose there is no more questions and we are just on time. So yeah, thank you so much, and I hope that this was helpful for you guys.
Hey,
So
yep, no more questions. So, yeah, we will be back next week on
mhm.
Thursday, March 31st, at 2 p.m. Eastern Time, for the second part of this series. Um, if you have a moment for today's session, I have shared the link to our survey. Right here, I'm putting it up again. If you have a minute to share your experience on our sessions, the event code is also on the screen. And finally, you can find us on YouTube, which is where this session's recording will be available. You can sign up for our next session, or just browse other um, Toronto Reactor sessions that we have on Meetup. We're also on various social media. And yeah, thanks again, Matthias, for coming in today. We're looking forward to next week's session.
Thank you for the opportunity, and see you next week.
Yeah, see you next week. Bye bye.